Okay, it's recording and the video is not frozen. Okay, so now we have our formula. Okay, so this is kind of where we are. I have no idea how much I actually recorded. Okay, so we find 15 degrees of freedom. When you look on your chart up here across the top, make sure you use 0.05 or the right number. There's also 0.005, so that's a little tiny guy, and that's what I was looking at. Don't do that. Okay, so when you're looking for that chi-squared number, you're really just looking for that number in there, and then we'll be using it in a couple different places. Oops, I'm clicking the wrong thing. Okay, so and then we're actually going to use that chi-squared number for some hypothesis testing. Okay, so find the critical chi-squared value for 10 degrees of freedom when alpha equals 0.05. This is a left-tailed test. So a left-tailed test is going to be a little bit different because when we usually think about this.
So wait, why is it
What?
left tail or right tail? Like
They tell you.
Are they just gonna tell us
Yeah.
every time?
Yes, remember in that formula that we were using last chapter, we had to say right or left. That is the only place where it matters. Right or left chi-squared. It was like in the formula, it looked like
Oh, and it had left and right. on the
chi-squared left. Yeah. So there were those two different values on there. Okay? So when you look at the picture in the book, it looks like this. Okay? Even at the bottom of the chart. So make sure you're able to read what's actually happening at that bottom of the chart. So it kind of shows an example. So a left-tailed test means I really want this value, but that's not what the book actually has. So where does this?
Left actually means right.
Yeah. So in order to find that, I have to find this total area. So if my alpha over here is 0.05% or 5%, what is this total area? So this guy over here is our 95%. I don't know if they're going to show this one on the picture. Oh, I'm not on the right one. Okay. So that 95%, now I need to actually go find on my chart where 95% is. Okay, so to find that value, it tells me my degrees of freedom. Go down the left column. 10 for degrees of freedom. 95% should be 3.94. Okay, so this is kind of just saying all the same things. So go to the next thingy. Go look under column 9.5. And we get 3.94. So make sure you're comfortable using that book chart on there as well. Okay, I can erase some of those thingies. Okay, some of them are just asking you to find those numbers. So we're just going to practice finding those numbers. So do you guys want to look at your chart as well?
Sure.
Thank you. Okay, so find the critical value for chi-squared values for 22 degrees of freedom when alpha equals 0.05, and it's a two-tailed test. So what that means is I need to separate that 0.05 into two places. This one, what? Yeah, 787. Well, you were in the right section anyway. So 0.05 means I'm going to have 0.025, 0.025.
So wait, I have to find 0.05 and then go down to 22.
No, you're not finding 0.05. You have to say what test is conducted. It's two-tailed. Draw yourself a quick little picture. Now I have to find 0.025.
Okay.
Okay?
Okay.
And then we'll
36.781.
36781.
Yeah.
36781. Then you'll have to do the other side, so the 1 minus 0.025.
So that would be 2.074.
They have 1098. So what are you looking at wrong?
I'm
So
looking at the other page.
don't look at the other page. Nope,
Oh.
those two charts have nothing to do with each other.
Okay, never mind.
One's
I'm
T,
not
one's
looking at
chi-squared.
that page.
So what we're going to do, instead of the 0.25, we're doing 1 minus 0.025. So then you have to do the 975. So find 975. 1 minus 0.025 is 975. Those are the two numbers you're finding.
Just 0.975? Yes.
Yeah.
22. Is it 10.982?
Yep.
Okay.
Okay, so just be comfortable finding those guys. I keep forgetting to click on these thingies.
I keep thinking it's like our Z chart.
No,
Like the jig where I can just look around. and
I know.
say,
It would be nice. It's not that nice. I'm not that nice. Yeah. Okay. An instructor wishes to see whether the variation in scores of the 23 students in her class is less than the variance of the population. The variance of the class is 198. So, whoops, I should have wrote down my formula, and I did not. Oh my God. Okay, so I have chi squared is equal to n minus 1 s squared over sigma squared. Okay, the variance of the class is 198. And is there enough evidence to support the claim? I have my n, that the variations of the students is less than the population variance. Population variance is that 225. Assume the scores are normally distributed. Okay, so we're going to plug this into our chi-squared dude here. And so we'll do chi-squared n minus 1. I don't know that this is necessarily the steps. This is probably totally not the steps because they want you to state the hypothesis first. So hypothesis and claim, is it equal to the population? Sigma squared equal 225 is our null hypothesis. Okay, I'm going to write all these guys down before I start trying to plug in things. H0, 225. How about sigma squared? I'm forgetting a sigma. Sigma squared for my variance is 225. My alternative hypothesis is sigma squared. All she says in here is different. I think it says whether the variation in scores.
That means it's not equal to. I remember.
What are they? Where does she say anything? Does she say different?
I don't know.
Is less. No, is less than the population. Sorry. Okay. Next thing they want is to find those critical values. Okay. For finding that critical value, is this a right or a left tail test? Okay. So after you draw your claim, after you state your claim, you guys, oh my God, you guys are all killing me. After you state your claim, what? Okay. Then you draw yourself a picture. Less than is a left tail test. At an alpha of 0.05, I need this area, but that's not the area that my book gives me. My book gives me this area, which is the same thing as 1 minus whatever that number is. Where's my alpha? 0.05. So I have to find 0.95 for a left tail test. Okay, so finding that alpha of 0.95, we go down. If I have 23 for my n, yeah, that's because you guys are talking and putting chapstick on each other. And
Chapstick on my
You have to say that. You didn't know.
yeah, I know, but that made it even better. Okay, so if I have 23 people, my degrees of freedom are 22. So at 22, at 9.5, you're looking in your chart to get that 12,338. So make sure you're comfortable finding that. Okay, so then we get that chi-squared value is 12.338. That's that critical number that would be like right here. Okay, so we're looking at those guys. Compute the test values when we're actually using this formula. The chi-squared for the actual data that we have. So n minus 1, I'm going to have 22. I'm not going to write 23 minus 1. S squared, they told us was 198. And then they told us our sigma squared was 225. Okay, so now I don't have a calculator. Does anybody have a calculator? Okay. 22 times 198 divided by 225. Oh, maybe we don't need it. Maybe they'll do it for us.
Okay. I was like, all
Okay.
your thingies are gone.
Yep, I know. 19.36.
Where are your shavings?
Okay, then we kind of put that on our graph, 19.36.
I like how you say maybe they'll do it for us, but you did this, didn't you?
It's in the PowerPoint. I found the PowerPoints. No, I'm lazy. I'm not, totally not that productive. Okay, so based on where that guy is in the graph, if that was 12, that's 19. Okay, are we going to reject it, accept it? So is there enough evidence to show that their variance is actually that much different than the population variance? Okay, so it's in that kind of the area that I think about that's not colored. I usually color my ends. So it's in that non-rejection area. We don't reject it. We don't necessarily say that we accept it. We just say we don't reject it. Okay, so there is not enough evidence to support the claim that the variation is less than that. You're all killing me, all of you.
Hey, at least I'm actually trying to do homework before the test.
I like it. I like it a lot. Okay, did you have that down? Okay. Okay, another one that will be really similar. So, a cigarette manufacturer wishes to test the claim that the variance of the nicotine contents of his cigarettes is 0.064. So I'm going to have, is a variance is sigma squared?
Don't put .0.
Oh. Nicotine content is measured in milligrams. I like it. And assume that it is normally distributed. A sample of 20 cigarettes has a standard deviation. Let me get there on that one, sorry. Where was I even at? Has a standard deviation of 1 milligram. That's a big difference. At 0.05 for our alpha, is there enough evidence to reject the manufacturer's claim?
Less than or equal to or different.
I don't see anything. So if it really doesn't see anything, it should just be the not equal to piece. And assume that is normally distributed a sample of 20 cigarettes at the standard deviation. Yeah. Yep, I'd say. Do they just have not equal to? Yep, they just have not equal to. Yay. Okay, so our sigma squared is not equal to 0.644. Okay, that makes, what am I writing? Why did I write that? Okay, that means we're going to have a two-tailed test at alpha equals 0.05. What that guy's going to look like is we're going to have, divide that by 2 to get 0.025. 0.025 over here, 0.025 over here is really the same thing as having a 97.5. So this guy is really 0.975 is what we're going to look up. Okay, so whatever those numbers are is what we're going to have in there. So using our little chart thingy, okay, we have those critical values, so we'll just make sure we can find those. So the critical values, make sure you're using degrees of freedom for 19. So go down to 19 on that left side. Critical value, so I need 97.5.
Wait, where? 97.5, and I'm finding what number? 16, 18, 24?
19 because it's one less than 20, which is what they told us we had.
So 8.907.
Cool, that's one of them they have. The other one, so we're going to kind of write that on our graph, 8.907. The other number we're going to do is still on that 19 row and 0.025.
32.852.
And that's what they have. Cool. So just make sure you can check your answers. So 32.852. Now we need to know where is this 1 milligram going to be at. Okay, so then we're going to have to compute the test value for that same, with that thing. So this formula, we have chi-squared equals n minus 1, which will just be our 19, times our s squared was just 1.00. Our sigma squared is 0.0644. Okay, I'm just making sure it's right, that I have the right sample and the right population one, because I just think it's worded weirdly, because I don't know which one is the manufacturer's claim or not. Okay, So what, 19 over 0.644? Okay. Ooh, see? Oh, I didn't even notice that. Is this the standard deviation? Oh, so make sure when you guys actually,
Phone on airplane mode.
yeah, it is. Isn't that great? Are you being mean to me? Is my phone gonna blow up when I turn it off airplane mode? Okay. No. Okay. Make sure you pay attention, because I didn't even pay attention. When this one said standard deviation, make sure you remember that the formula is asking for variance. It wouldn't have mattered, it's still 1. Okay, but just pay attention to that. Okay, 29.5 is 29.5 on any of those outer regions? No, 29.5 would be in here somewhere.
It's not 0.0644. It's just 0.644.
Sorry, I wrote it wrong. It's okay.
Okay, and that's what they're in.
No, they have the right thing still. What? Stop. What are you guys doing? Gross. Okay, so it's within that region. Don't reject it. So, and then you don't really have to, basically this little graph that your chart, whatever it is, that you're making the whole time, you don't have to redo it just because, like you could write like right here, don't reject it. No rejection. And then the fifth step is actually, what is your conclusion going to be? There's not enough evidence to reject the claim. Okay, if it was outside, you would say there is enough evidence to reject the claim. Okay, you guys want another one? This is the relationship between confidence intervals and hypothesis testing. I just want to read this to you. When a null hypothesis is rejected in hypothesis testing, the hypothesis testing situation, that is like, you have to mumble through that hypothesis testing. The confidence intervals for the mean using the same level of significance will not contain the hypothesized mean. Likewise, when the null hypothesis is not rejected, the significance will contain the hypothesized mean. So it kind of seems a little bit counterintuitive there. You said no more? Okay. So then I will make you guys do problems. For number 1, I'll make you do number 1. And there's a lot of different pieces for number 1. I want you to do all of them. There's like A through H, but I think it will be good. And that is just all using that chart. 4, 5. And 5, 7, and 12. Okay, and there you go. I'm recording.